To find A, we need to know that when there are two tangents to a circle that meet at the same point, that means the two tangents have equal lengths, so A is also 16 centimeters. To get B, we need to look at this inscribed quadrilateral. So the property that we know about inscribed quadrilaterals is that opposite angles are supplementary, meaning they add up to 180 degrees. So B plus this equals 180 degrees. But since angle M we know is 90 degrees, then B is also 90 because 90 plus 90 equals 180. Okay, to get C, we need to use this 42-degree angle. So this 42-degree angle cuts off arc LS. So then this angle is an inscribed angle of LS. So then the measure of LS is 42 times 2. So LS measures 84 degrees. But arc LS also gets intercepted by angle LZS. So this intercepted angle is half of the arc. Okay, so it makes sense that this angle and this angle are both 42 degrees because they cut off the same arc. Okay, so to find letter D, we can look at that same quadrilateral as before, but now this angle plus 68 has to equal 180. So this angle is 42 plus D. The other angle is 68, and together they combine to 180. To get E, we can look at this smaller triangle. We know triangles have a total of 180 degrees. So far, we've used up 90 plus 42. We've used up 132 degrees. So we take that away from the 180 total. Means that E is 48 degrees. And then E and F are supplementary. They add up to 180. So I've used up 100 out of the 180 degrees. E uses up 48 of them. That leaves 132 degrees for F. Okay, now measure in degrees of LZM. Okay. So LZM is from here all the way to here. So I think it's actually going to be easier to find the part that it doesn't hit. So this 68-degree angle intercepts this arc over here in blue. So since this is an inscribed angle, I do 68 times 2. Means that this arc is 136 degrees. And then since the arc I'm asked for, LZM, is everything except for that arc, we know that a full circle has 360 degrees. We take away the 136, and that leaves 224 degrees for LZM. Okay, asked for the length in centimeters this time of that same arc LZM. Well, we're told that the circumference of the circle is 32 pi. So 32 pi is the full circle, but we don't have the full circle. We have 224 out of the 360 degrees. So doing this calculation leads us to the answer of approximately 19.9 pi. Length of KLZ. Okay, so to find the length of KLZ, it's useful to look at angle M down here. So angle M cuts off the arc we care about, KLZ, and angle M is 90 degrees. So since that's an inscribed angle, you multiply it by 2 to get the arc measure of KLZ is 180 degrees. So again, the full circumference would be 32 pi, but we don't have the full circumference. We only have 180 out of the 360 degrees. So this calculation leads to 16 pi. Okay, and then area of circle Q. Well, we're told the circumference is 32 pi, but we also know the formula for circumference is 2 times pi times the radius. So we can solve this for r, divide both sides by 2 pi, and we get the radius is 16. And then the formula for area of a circle is pi r squared. So now that we know the radius, we input that. Okay, if circumference equals 5 pi, then what is the radius? Well, the formula for circumference of a circle is 2 pi r. So if we divide both sides by 2 pi, we get that r is 5 divided by 2, or 2.5. If circumference is 24, then what is the diameter? So circumference is 2 pi r. So we divide both sides by 2 pi to isolate the r. Okay, 24 divided by 2 is 12, and then we have a pi in the denominator, 12 over pi. If diameter equals 5.5, then circumference equals, well, formula for circumference is 2 pi r, but 2 times the radius is the diameter, so another formula for circumference is pi times diameter. So we already know the diameter, so it's diameter times pi. If circumference is 12 pi, then what is the area? Okay, well, circumference is 12 pi, circumference is 2 pi r. So we can solve for r by dividing both sides by 2 pi. So r equals 12 pi over 2 pi, which is 6. So the radius is 6, but we need the area. Area is pi r squared. So now that we know the radius is 6, 6 squared times pi is 36 pi. Length of ROT is 116 pi meters. What is the radius of the circle? Well, we're given that minor arc RT is 120 degrees, so that means that 360 degrees in the circle total. Take away the 120 over here. That means that the rest of the circle has a measure of 240 degrees. Okay, so the general formula for arc length, you take the full circumference of the circle, you multiply it by how much of the circle you actually have. So in this case, we have 240 out of the 360 degrees total, and that equals the arc length. And in this case, we know what the arc length is. It's 116 pi. So now we need to solve this equation for r. So the fraction part simplifies to 2/3. Okay, we can divide the pi out from both sides. 2 times 2/3 is 4/3. And still have the r. Okay, so multiply both sides by 3/4 or divide both sides by 4/3. They're the same thing. And you'll get that the radius is 87 meters. What is the length of AB? Well, first we find the full circumference, 2 pi r, in this case r is 6, and then you multiply by what fraction of the circle you actually have. In this case, AB is 120 out of the 360 total degrees. So now we simplify. 120 out of 360 simplifies to 1/3. So this turns into 4 pi. Okay, the circumference is 24 pi meters and CD is 60 degrees. So what is the length of CD? Well, so if arc CD is 60 degrees, the central angle is also 60 degrees. But we actually probably don't even need that. Okay, so circumference is 24 pi. And the formula for circumference is 2 pi r. So let's get the r by itself. Radius of the circle is 12. Oh, sorry, we actually didn't even need that either. So the full circumference is 24 pi, and arc CD takes up 60 out of the 360 degrees. So we just need to simplify this to find the arc length. Question 8, length of XY is 14 pi. What is the diameter? Okay, so we see an inscribed angle, and we know that the inscribed angle is half of the intercepted arc. So if you multiply the angle by 2, you get that the intercepted arc is 160 degrees. Okay, so we're not sure what the full circumference is, so I'll just write the general circumference formula, 2 pi r. But I know that the arc takes up 160 out of the 360 degrees total, and it has a length of 14 pi. So now I need to solve this equation for r. And I'll start by dividing both sides by 2 pi. Okay, then 160 over 360 simplifies to 4 over 9. Okay, so divide both sides by 4/9, and I get a radius of 15.75. But I was asked for the diameter, not the radius, so I multiply that by 2, and I get the diameter is 31.5. Calculate the area of the sector. So just like with circumference, we first start by finding what would the full area be. Area of a circle is pi r squared. In this case, the radius is 16. So the full circle would be 256 pi, but we don't have the full circle. We have 240 out of the total 360 degrees. So 240 out of 360, that simplifies to 2/3. So that means our area is 512 over 3 pi feet squared. What is the length of AB plus CD if the radius is 12 meters? Okay, so I need to know about arc AB. I noticed that AB is intercepted by inscribed angle ADB. The inscribed angle is 22.5 degrees. So if I multiply that by 2, I get that arc AB is 45 degrees. Okay, I also care about arc CD. So CD gets cut off by angle A, which I don't know yet, but I can figure it out. This small triangle, all triangles have 180 degrees, and so far I've used up 105 plus 22.5. I've used up 127.5 degrees. So since I have 180 degrees total, I subtract, and I get that angle A is 52.5 degrees. So since arc CD is intercepted by the inscribed angle A, I know I multiply the inscribed angle by 2 to get the arc measure. So CD measures 105 degrees. So put together, arc AB plus arc CD is 45 plus 105 is 150 degrees. So even though it's split into pieces, combined, I've used up 150 degrees. So the full circumference would be 2 pi r, and r is 12. But I don't have the full circumference. I only have 150 out of the 360 total degrees. So when you multiply these together, you get 10 pi meters. If the area is 256 pi meters squared, what is the circumference? Okay, area of a circle is pi r squared, but in this case we are given the area is 256 pi. So we need to solve for r. We can divide the pi from both sides. 256 equals r squared, square root, and we get that r is 16. Then once we know the radius, we can use the circumference formula, 2 pi r. But again, we know r is now 16, so the circumference is 32 pi. Length of arc TV is 12 pi inches. What is the diameter? Well, arc TV is intercepted by the inscribed angle of 80 degrees. So you multiply the inscribed angle by 2 to get the measure of the intercepted arc. Okay, so I don't know the diameter, which means I also don't know the radius, but I know the general formula for a circumference is 2 pi r. Then I multiply by the fraction of the circle I actually have, and I have 160 out of the 360 degrees total. And that tells me that the arc length is 12 pi. So now I need to simplify for r. I can divide both sides by 2 pi first. Okay, so 160 over 360 simplifies to 4/9. So if I divide both sides by 4/9, I get the radius is 13.5. But I was asked for the diameter, so I multiply by 2, and the diameter is 27 inches. Area, the shaded area is 120 pi, and the radius is 24. What is x, the central angle? Okay, so the full circle would have area of pi r squared, in this case pi 24 squared. But I don't have the full circle. I have x out of the 360 degrees total. But I know that this answer is 120 pi. Okay, so now we need to solve for x. We can divide pi away from both sides. 24 squared is 576. Okay, so next I can multiply both sides by the denominator of 360. and then divide both sides by 576. So x equals 120 times 360 over 576, which simplifies to 75 degrees. Shaded area is 12 pi, find the radius r. So we're working with area. The area of the full circle is pi r squared, but since we don't have the full circle, we only have 120 out of the 360 degrees, and that is worth 12 pi. So we need to solve for r. Okay, so we can divide pi away from both sides. 120 over 360 simplifies to 1/3. So multiply both sides by 3. We get r squared equals 36. And then r equals 6 centimeters. Solve for the length of chord JL. So we have two intersecting chords. So the property states that the product of each chord's pieces is equal. So x times 10, I multiply together the pieces of the first chord. That will equal 5 times 12, the product of the pieces of the other chord. So 10x equals 60, x equals 6. But they didn't ask for x, they asked for chord JL. Okay, so if this piece is 6 and this piece is 10, the total length is 16. Okay, 16, it doesn't actually ask a question, but there's a variable here, so we're going to solve for that. So we're given this arc is 232, so that means that 360 total minus 232 means 128 degrees left over for this smaller arc. But we're trying to get x, which is a circumscribed angle. Its vertex is outside the circle. So the only property we know about circumscribed angles has to do with central angles. So we're going to go ahead and draw in a central angle. Okay, so this new central angle intercepts the arc of 128 degrees, and central angles have equal measure to their intercepted arc. So this angle is 128 degrees. And then we know that circumscribed angles and central angles that intercept the same arc are supplementary, meaning they add up to 180. So x plus 128 equals 180. And we get x is 52 degrees.